Hello, everyone, and welcome to today's webinar. This is the 4th episode of our 12-part webinar series on countermeasure strategies for pedestrian safety. My name is Dan Jolene, and I'll be leading the webinar today. Today's webinar is going to focus on curb extensions, bulb outs, and neck downs. And we are going to be speaking today with Pete Rush. Pete worked with the Wisconsin Department of Transportation for more than 30 years, followed by about 5 years, a little more than 5 years with the Federal Highway Administration. So we're really happy to have him here today, and we're thrilled that you all took some time out of your day to join us. Attendees, if you can hear me, if you can just please click the hand icon in the upper right-hand corner of your screen to raise your hand. This will let me know that you all can hear me. And that things are working as they should. Okay, seeing some hands going up. Fantastic. All right. That's great. Glad you're here. Glad you can hear me. I think we've got a really good presentation prepared for everybody today. So let's get right into it. Before we do that, I just want to cover just some boilerplate background information and administrative details. If for some reason during the presentation your computer freezes, you can reload the website and log back into the program. You should be able to join us where you left off. We have already posted the presentation slides as a PDF file to our archive page. I'll be sending out the link to you all just shortly. You can go ahead and download, if you like, a copy of the PDF slides so you can refer back to those after the presentation today. We will also be posting a video recording of the webinar to that same website within about 1 to 2 weeks. You'll be able to look back at that video to refer back to parts of the presentation that you missed or anything you'd like to share with others. Again, that video should be available within about 1 to 2 weeks. Please note that attendees won't be able to speak during the webinar, although you will have the ability to submit questions and comments using the chat function, and I'll be monitoring these throughout the webinar. You can ask your questions at any time. We have held about 20 to 30 minutes at the end of the webinar specifically for a discussion period. So when we get into your questions at that point, feel free to just submit those at any time, and that's when we'll get to them toward the end of the presentation today. Later today, everyone will be receiving a follow-up email from the UNC Highway Safety Research Center with the link that will allow you to download a certificate of attendance for this webinar. Now, if you're attending the webinar with multiple attendees at your site and you are the one who registered, you'll be getting that email, and it'll be your job to pass that information around to all the other people in your group so that everyone can generate their own certificate of attendance for the webinar. The email that comes out later today will also contain the link to the website where we've already posted the presentation materials from today's webinar. And that page will also include the video recording of the webinar within about 1 to 2 weeks. The webinar has been submitted and approved by the American Planning Association for 1.5 CM credits. If that applies to you, if you collect CM credits, please go to the APA website. You should be able to find this webinar right there in the event calendar and claim your credits there. To learn more about the PBIC webinars or to check out past webinars as part of this series or others, you can visit pedbikeinfo.org/webinars. Many of you may be attending this webinar after attending the first 3, or maybe this is your first one in this series. I'm putting up on the screen now the next 3 webinars we have in our schedule. We're going to be covering rapid flashing beacons, pedestrian hybrid beacons, leading pedestrian intervals, all between now and early December. So if you're interested in these topics and you want to learn more, just check out our link there. You can find the registration links to these and all the other webinars in this series. Again, we have 8 left after today, so there's still plenty of time to take a look at what we've got coming up and also to refer back and watch the videos from the past episodes. Before we get started with the presentation today, the last thing I'd like to do is to launch a quick poll. We want to know about how many people are attending the webinar from each of your sites. In many cases, it may be just you at your computer. You may have a couple of folks with you, or maybe a larger group, 4 to 5 people, 6 to 7, or even 8 or more. If you could just select the response that best applies to your group, we would really appreciate the information. We're just trying to get a handle on how many people are attending the webinar and whether people are attending in groups or just by themselves. So we'll take just a few more seconds to look at the feedback from the poll, and then we will close it up and get right on with the presentation. Okay. All right. Well, thanks very much, everybody. I'm going to go ahead and close the poll now, so we have plenty of time for Pete's presentation. Thanks for all of your feedback there. Without too much more delay, we're going to go ahead and get started. So, Pete, I'm going to be giving you control of the screen. Go ahead and accept that whenever you're ready, and show your screen, and we should be able to see your presentation slides.
Okay, do you see it?
I do.
Is it a full screen?
I do see your presentation notes as well.
Okay.
So you may want to switch back just to the standard slideshow view.
Right. Okay, I'm going to have to, can I get out of this? No. Okay. Is that okay?
That looks
okay.
Good. Go ahead and take
All
it
right.
from here.
Okay, good. So to begin with, what is it that we know about curb extensions, bulb outs, and neck downs? And that's what this webinar is essentially all about. And to begin with, some of the key points are, obviously, as you all know that have used them somewhere in your community or another community, there are a variety of different types of bulb outs and neck downs. And really the goal of them is to improve pedestrian safety and service. If they are designed right, and that's a big if, and we'll talk about that in a couple of the case studies that we have here during the webinar, they will also be an enhancement to motor vehicular traffic and the entire community without disrupting emergency services or the flow of stormwater runoff. Another issue that has to be addressed by you folks that may be thinking about putting in these curb extensions of bulb outs or neck downs. And we'll go into detail on that too. We will also detail the best design and how to build curb extensions, bulb outs, and neck downs. And these, of course, to enhance conditions for all roadway users. And we will also discuss drainage and cost, again, two of the major considerations for roadway agencies. Okay, as I go through the presentation webinar, I will be trying to address some of the questions that were submitted prior to the webinar in some detail, and then again at the end, if these have not been addressed adequately, we'll come back to that, and Dan will lead that discussion. So when and where do we put in curb extensions? And I'll leave it just at that term rather than trying to say all of them every time. Where there is limited sight distance, in other words, you have a narrow street perhaps, and there's very limited sight distance between pedestrians and vehicles, and in some cases between vehicles and signs. Again, where you may want to put in another curb ramp or you already have one, or you put in two curb ramps during a reconstruction project. We know that they discourage high-speed turning traffic, which is important for pedestrian safety or reduce pedestrian risk. And it's also a place where you can accommodate a high number of waiting pedestrians on the corner. Some folks refer to it as a reservoir on the corner. So where do we put them? Wherever there is 24/7 parking on street, that's a candidate for a curb extension at the intersection. They can also be put at mid-block, which is another question that was submitted, and we'll talk about that more in detail a little later on in the presentation. What we have talked about early on was the need for better visibility for the pedestrians at the corner. And as you can see in this slide, clearly that there is a pretty good sight distance between the vehicles and the pedestrians and the bicyclists, and for the pedestrian to see the bicyclists and the oncoming motor vehicles. So it definitely gives you a better visibility with the curb bulb out than just a normal intersection. Here's an example. This is before condition. And notice there's a space up here that near the intersection that is not used by a vehicle. And then here's the after condition with the curb bubble. Can you see my mouse?
Yes.
Okay, good. In this case, there is a vehicle that's parked in that last spot, and so it looks like the pedestrian is less visible. But keep in mind also that this picture is taken from the viewpoint of the passenger in the vehicle, not the driver, who would be farther over here, so they would have better visibility of the pedestrian. And of course, it provides a safer place for them to stand because there is the curb that would discourage vehicles from trying to get over that curb. Okay, here's an existing situation, and as we'll see, the curb extensions become a win-win situation. As you'll notice, here's the stop signs for this approach, and they did put in a left-hand stop sign because the right-hand stop sign, which is the required sign, probably isn't too visible, and if you have a panel truck or a large truck over here, then of course you can't see the stop signs. Here's the after condition. Curb extensions were put in. The stop signs, of course, are much more visible now to approaching traffic. Pedestrians will be more visible as they approach to enter the crosswalk. And if you're on the cross street traveling, of course, it's a win-win for you, where you might avoid a right angle collision of a vehicle blowing a stop sign in the prior condition, where the stop signs were not very visible. Here we have a case study from Cambridge, Massachusetts, and this is the first one. We'll have another one at the end. This is a case where the city faced a problem of motorists traveling at high speeds and neglecting to obey the stop signs on a street called Berkshire. The area had a large number of pedestrians due to a nearby popular park, so they had small children, was a large percent of that pedestrian population, but was also a common road for motorists as an alternative to a much larger arterial road that had more delay probably than some vehicles wanted to deal with, and that street being a high volume street, the parallel street, cutoff streets, getting to adjacent parallel streets is what many people try to do, and curb extensions can reduce that potential. The background, Berkshire and York Streets are located in a neighborhood of Cambridge, a residential mix of businesses and retail shops. Berkshire is a neighborhood street with a 25-mile-per-hour posted speed limit and a 2,000 to 2,500 ADT count. Okay, here's the next slide that shows where that is. A school, a playing field, and a youth center and library are adjacent to the street. Neighborhood residents had long complained over a long period of time about speeding vehicles, and police checks finally confirmed that, yes, in case that was the fact, along Berkshire, and they also found in their evaluation that there were a large number of drivers running one stop sign at the intersection of York and Plymouth, which was in the area. So what was the solution? The city of Berkshire York Street area was chosen by the city to demonstrate how traffic calming could address neighborhood transportation problems. And remember, I mentioned right up front about doing it right, and we'll discuss that at the end of this slide. Working jointly with our city traffic department, the public works, the community development department, they publicized and facilitated an open planning process involving many neighborhood residents, school personnel, and emergency services personnel as well. The Department of Public Works implemented the improvements using city funds. What did they do? They implemented curb extensions at 3 intersections. They reconfigured the street to make it one-way. A raised crosswalk was added. Raised intersections were constructed. 2 chicanes to slow traffic were added. The fence opening for the adjacent ball and park field were relocated to line up with the enhanced pedestrian crossings, encouraging pedestrians, especially children, to cross where it was safe to do so. And we all know that a crosswalk does two things. It tells vehicles where to expect pedestrians to cross, and it lets pedestrians know where it is safest for them to cross. The raised crosswalk and intersections were constructed with concrete pavers that replicate the feel and look of brick, but they are more durable and have a slip-resistant finish. It was done in 3 phases with 20% local and 80% federal funds. Now you can see after how the curb extensions visually narrowed and actually physically narrowed the approach to the intersection, making vehicles more than likely slow down. And here's looking at the cross street, and here are the curb extensions that were added here at the one intersection. The results? Overall, the neighborhood is now a much safer place for pedestrians. Before the improvement, the 85th percentile speed on Berkshire Street was 30 miles per hour, and only 41% of vehicles surveyed were traveling at or below the 25-mile-an-hour speed limit. After the improvements, the 85th percentile speed was reduced to 21 miles an hour. That's a 9-mile-per-hour drop, which is quite significant. And at the vertical traffic devices, and 24 miles per hour in between, and 95% of vehicles are traveling at or below the speed limit. Again, that's quite remarkable to find that. The curb extensions reduced the width of the pedestrian crossing distance, which then limited pedestrian exposure time to traffic. It improved visibility between motorists and pedestrians, and it slowed the turning vehicles. All of the things that are benefits of putting in a curb extension. A post-improvement survey of the neighborhood residents found that 44% liked the improvements, while only 28% disliked them. I suspect the dislike is probably with the raised crosswalk and the raised intersect. It's not necessarily about the bulbouts, but I don't know that for a fact. 47% reported perceived increase in pedestrian safety, and 39% reported feeling an improvement in the safety for children playing. Interestingly, 61% reported that it was harder to find on-street parking, despite the fact that there was only one parking space that was eliminated. When you take parking away in an area where you have a lot of merchant activity and retail activity, that one space seems to be like a golden parking space. We'll talk more about that a little bit later on in the presentation. The real benefit, the city considered the project a major success, both for the implementation of effective traffic calming measures and for the ability of the public participation process to mobilize the neighborhood and generate support for the improvements. The Berkshire York Street project has led to the development of several other neighborhood projects throughout the city. That is a very, very key point about doing it right to begin with. And if you don't do it right to begin with, if these are some of your first ones that you're implementing, it's going to be more difficult than in the future to try to get any projects planned and implemented in your community. So do it right, get all the folks involved that need to be involved, and your chances for success for future projects will increase quite dramatically. So what do we know about the benefits of curb extensions, the safety benefits? There are some numbers out there from some studies that have been done around the country, but the results have not been validated yet through rigorous research. So they are not on the CMF Clearinghouse website, and I've noted that website there in the first bullet point. So if you're doing a study in your community, a nice before and after study would be great, the 3 years before and the 3 years after. You have some control sites available that you can refer to, and send that into Federal Highway or the Pedestrian Bicycle Information Center here, and we'll certainly add those to the clearinghouse information that's available. You might want to take a look at that for other issues related to safety as well if you're not already familiar with that. What do we know about them intuitively, though? They increase pedestrian safety, they increase the visibility, they allow pedestrians to better observe approaching motorists, so it's a win-win for both. They decrease the crossing distance. They reduce pedestrian exposure to traffic by the reduction in crossing distance. They can reduce speeds by visually narrowing the street and physically as well. They slow turning vehicles more so than a typical intersection. And they can improve the signal timing by reducing the amount of time needed for pedestrians to cross the intersection. Here's some safety research. An Oregon study, pedestrian safety impacts of curb extensions. Again, they didn't have the validated information, and therefore the CRFs or the CMFs are not in the clearinghouse. But they do cover yielding rates, and that's one of the important things that you want to know about the before and after condition. How are vehicles now yielding to pedestrians with the new curb extensions? They looked at safety performance, and then here's a study from New York City as well, and you'll have these documents for these PDF file, I think it is, Dan, that you'll find all of these safety research reports. Okay, here's a slide that about the benefits and liabilities. And the table is replicated from the Signalized Informational Guide, and this is the guide over here. And the table is made up of the characteristic, and we see safety operations and so on down here, the potential benefits in the center column, and then potential liabilities in the column on the right. And safety, for example, as we look at the benefits, there is a reduction in right-turning vehicle pedestrian collisions. That's been borne out by some studies, but not validated. And it's also observed that there are fewer right turn on red violations. What are some of the potential liabilities? It may increase right-turning vehicle rear-end collisions by creating a differential between vehicles that are turning right and those that want to go through at the intersection. So it's possible you may have some collisions based on that condition. It also could potentially affect large vehicle off-tracking, and we'll talk a little bit more about that perhaps at the end when we, or another question that came up about what do you do about those large vehicles. So you need to at least think about, okay, designing your intersection for the largest vehicle that you would expect to be operating through that intersection. Now most of these, or many of these are going to be in urban areas, the downtown areas, so you may not have much large vehicle traffic. We'll come back to that a little bit. Operationally wise, less overall delay due to reduction in time needed to serve pedestrian movements. So you can allocate a little more time to vehicular traffic by reducing the pedestrian crossing times. And liabilities, you may adversely affect operational extensions to replace a travel lane if you need to replace a right turn lane, for example, to put in the curb extensions. That could affect the operations of the intersections. Emergency vehicles may be significantly delayed as well. So you need to get the emergency services folks, again like the Cambridge study, involved in your process, planning and designing your curb extensions. The thing about emergency vehicles is, though, that they are now using every street in your community more than likely to respond to a fire. The fire vehicles are going to be the ones that are most apt to be delayed. So they're going through intersections that are much worse or tighter than a curb extension intersection would be. So they know how to do it. And if you let them know and perhaps even create a map of where these are in your community, then they'll certainly take that into consideration when they're making their routes to the fire or whatever it might be that they need to respond to. Multimodal characteristic, potential benefits. You have the shorter crossing distance. It facilitates the use of two perpendicular ramps and a signal diagonal ramp, which is sometimes referred to as an apex ramp, and we'll point out a few of those in some upcoming slides. And there's better visibility between pedestrians and drivers, as we showed in the slide right up front. What will it do to large trucks and buses? That's a potential liability, but those can be addressed, I think, for the most part, if your design is done correctly and they're in the right location. Physically, potential benefits, not identified, potential liabilities. What do you do about drainage? And we'll discuss that in some slides near the end of this webinar. Socioeconomic, the costs are low to moderate, and we'll have a table showing you those. Liabilities, none. And how about enforcement, education, and maintenance? No potential liabilities and no potential benefits identified. In terms of liabilities, pedestrians, because it's part of the sidewalk, really don't need any information about how to use the curb extension, but as an agency, you may want to get out some public information before they're installed to let the folks in your community know what's going on and why you're doing it. Here's some design guidance, the New York City Street Design Manual, and I encourage you to go look at some of these. The State of Washington Design Manual on pedestrian facilities, both very good resources. They'll give you some more information beyond what we're able to communicate in this short 90-minute presentation here today. Here's some guidance from the Washington Design Manual. The first is extend the curb no further than the width of the parking lane. So that typically will be about 8 feet. Design the approach nose to ensure adequate setback to parked vehicles to provide visibility of pedestrians. And we'll show that coming up in a few slides. At traffic signals, curb extensions can reduce the pedestrian signal timing because of the less crossing distance, and so it could potentially enhance the efficiency for your vehicular traffic. Here's a single point location here that we talked about. This is not good for ADA. It leads a person that's blind right directly into the intersection, and they don't really know where they're going. Maybe after a time or two, they'll figure out, oh, they'll get helped from somebody else at the intersection. But we'll show some real good examples of what you really want to strive for that will do a much better job of meeting the ADA guidelines and requirements. Okay, when not to use curb extensions. This is what the Washington State Design Manual says. Do not use curb extensions on state highways when the design vehicle approach encroaches on curbs or opposing lanes, on-street parking is not provided or allowed, and the posted speed limit is 40 miles per hour or above. Well, let's get back to the design vehicle again, encroaching on the curbs or the opposing traffic lanes. Many are long, there may be long truck routes in your community on a national network where you're planning to put in bulb outs or curb extensions. If that's true, if it is a national long truck route, you cannot prohibit trucks from using that intersection or that street. And they also are able to use local streets for deliveries of whatever it is they might be hauling to that local community. I've got a few slides at the end. If we have some time, I'll show you a little bit more about that. But that's something you need to take into consideration. Is it a long truck route? And if so, maybe it's not a good location to install a curb bulb out. Okay. Are curb extensions on one side of the street or the intersection a good idea? In this case, we only have one over at this location. The other side, there's a right turn lane here, and there's only one through movement. And some of our instructors were at this actual intersection, and they observed a vehicle in this lane trying to beat through traffic over here and get in. And so there's a potential that vehicles that may try to do that or mistakenly drive straight ahead could enter onto this curb bulb out. So what they have done in this location, they installed bollards which help protect those people that may be in this location. Another alternative would be to put in a small island here, a pork chop island that would direct the right turning traffic into that movement, and they would have to run over that island before they got to the curb extension on the opposite side. So that may be also something that you might want to consider if you have a situation like that in your community. Here's the New York City design guide about dimensions of bulb extensions, and there have been some questions about how do you most effectively design a bulb out, and we'll have quite a few slides that will show you different characteristics here. In New York City, the width is typically 2 feet less than the width of the parking lane. And also the curb extension cannot extend into a bicycle lane if there's one on that street adjacent to the traffic lanes. And they have a minimum curb extension length typically equal to the full width of the crosswalk. In other words, you'd have at least this width. And they may also have an additional width beyond the location of the edge of the building, the adjacent buildings that house the retail shops and so on along the street. Here's San Francisco. Better streets, typical bulb out dimensions. The curb radius, again, as we talked about, is determined by the design vehicle. And again, like your emergency vehicles, many of the people that are delivering to your community, even if it is a long truck, for example, the 53-foot trailer, I had one deliver some wood to my house one time, and I'm in a pretty residential area with narrow streets. The 53-foot trailer had no trouble getting to me. He did ask how the best way to get out would be, and of course I accommodated him with that. But again, they can also use your local street network to deliver products to maybe a hardware store or a lumberyard or whatever you might have that they're destined for in your community. And so they know how to get around these things, and they may actually move over a little bit into this lane to make that turn. And if you have a bike lane that's adjacent to your travel lane here, that gives them a little extra width to make that turn. Or they find an alternative route, and that's another possibility. If it's a long truck route, you cannot prevent those long trucks from using that street, but you can suggest an alternative route perhaps if there's a location where you are having problems with the design vehicle and how to accommodate them. Here's, again, is the 5-foot length I talked about from the edge of the buildings, the minimum length here. Then you have a taper going back to the curb, and this width is, let's see, 8 feet in San Francisco. Why is it different between New York and San Francisco, or the West Coast? Well, more than likely the streets in the East Coast that were originally designed were narrower. The buildings are built that way with the narrow streets. They remain that way so they don't have as much luxury as you folks out in the West Coast have, who were able to identify some of the problems that the East Coast folks have and build the streets wider so you can allow more flexibility in the width of your curb extension. And this would be 8 feet, which is determined by the adjacent lanes. And again, the 5-foot distance here. Washington, D.C. doesn't allow further than 6 feet. And again, they talk about one of the reasons is potential for future bike lanes. And again, those streets were designed many years ago too, and many of them are narrow, so that's probably one of the reasons why it's the lesser distance. San Francisco, so what do you do about the radius of the corners on your curb bulb out? When you have the last parking space, the inner radius, as it's called, in San Francisco, they like 20 feet, and the outer radius, they like 10 feet. That enables your street sweeping machines to sweep the entire curb line. And there were a number of comments about that, and also a number of comments about okay, what do I do about snow removal in the northern climate? And again, a design similar to this is probably going to accommodate your snowplow operators. And they will figure it out how to do it. But you also need to know, or let them know, your Department of Public Works, where you have the curb bulb outs. And probably the most important one to consider is the mid-block crossing, because at intersections they're likely going to be going very slowly in their plowing operations anyway, so they shouldn't have a problem like they would traveling down a street at, say, 10 to 15 miles per hour or more plowing, and they come upon a mid-block bulb out. So hopefully through good discussion with them about what you're doing and why, they will be able to figure it out. And we'll see Minnesota has a little bit different design, and of course they're a snow state, and they were able to accommodate that operation as well. It may be in San Francisco, they may reduce to 15 feet. They don't get much snow out there. And again, as low as 10 feet. San Francisco also has some non-standard returns that they can use. I don't have any particulars on why they use these, but they have a 90-degree return shown here. And of course, what that does is create a difficult problem for street sweepers, obviously. So there are maintenance issues, and that's covered down here, and more costly to maintain. If a vehicle parks right up next to this curb here in this kind of return, and somebody comes up right on their back bumper, they're going to have a very difficult time getting out of that parking space. And here's a 45-degree return over here. Again, they haven't done much to accommodate the street sweeping operation. So while they're non-standard, they do create, and are probably used very infrequently, they do create a more difficult and costly situation to maintain. Also from San Francisco, here's an option about how you design your curb bulb out. And these are two things, two options. And we had a question from one of the participants about, I want to use a 15-foot radius, and that's probably about what this is, but I'm being told that the curbs will be run over by large trucks. Well, as you can see, even though this has a larger radius here, this has a smaller radius, the turning effective radius is the same for a vehicle. What's different is that your curb bulb out is only 4 feet rather than perhaps 8 feet, or maybe 6 feet. But so you have less distance to accommodate pedestrians waiting over here, and your curb bulb outs can be a little bit smaller. So that's the difference in how you can do things. So if you want a 15-foot, you can do it. You'll just sacrifice the less of a curb bulb out, which means you're going to have a little bit more travel time and distance for the pedestrian to cross the street. Depends upon what this distance is. If it's 4, you've got 4 additional feet on each side. 8, if it's 6, you've got 3 additional feet on each side. So it'll take a little bit longer to cross that intersection, and a little bit more exposure as a result of that. But both can be accommodated. And as I mentioned before, larger trucks, if they can, they will sometimes sweep out a little bit and make that turn that way as well. And probably many of you have noticed that, or even allowed trucks to do it in front of you. I know I have. Another question came up about, okay, what do we do about bus bulb outs? Are there examples? Well, here we have examples from the New York City Street Design Manual. With this design, as shown here, the bus doesn't have to maneuver in and out of traffic. This is almost like a mid-block curb bulb out, or curb extension. There may be parking in advance of it, and there may be parking after it. And it creates room for the bus shelter. It's not in the walking zone for the pedestrians that are on the street. Here's the shelter here. It's away from the sidewalk. The bus patrons largely wait in the curb extension, as you can see here. so there isn't interference with people that want to use the sidewalk. And when folks are getting on or off the bus, they aren't directly lighting into the pedestrians that are walking along the sidewalk. So there's some advantages, particularly in the larger urban areas where you have a lot of pedestrians and a lot of bus traffic. So here's an example. The 6 to 8 feet for the curb extension. The curb is 6 inches to 10.5 inches high, and it may be 40 to 150 feet long, and that probably depends on how many buses are likely to stop there at any one time, if there are multiple stops or bus routes at the location. Here's some more examples. New York. One of our instructors refers to these as floating curb ramps. As you can see, the drainage, there is a drain here, and we'll catch some of the water coming around the corner, but the other flow is allowed to go between the curb and the bus bulb. So that's how the additional drainage is handled. The one disadvantage here is you don't have a nice taper here for vehicles that maybe get caught in this area. Probably not a real big issue. Notice that they do have an iron fence here, so that channels pedestrians that getting on and off the bus get down at this location here. Here's Seattle. A bike lane runs through the area between the sidewalk and the bus bulb. Here's your shelter again. And then here is San Francisco. They had the taper here, and they have a little drain here. They've chosen to accommodate the water with this drain that is covered up by some type of a cover, and we'll talk a little bit more about that in the drainage examples. But 3 good examples of how you can accommodate a bus bulb out, and they don't take a lane because this is buses only lane. Okay, a lot of questions about drainage, and this can get a little bit complex. What's really important to recognize is that you must design your curb bulb out to maintain storm drainage and prevent ponding, so pedestrians don't have to walk through a big puddle to get through the intersection from the bulb out. So what are your options? Well, one is you can relocate the catch basins. That's going to get very costly real fast, though, and maybe on the scope of any budget that you might have to build curb bulb outs. So you're going to want to use other alternatives. So you can channel the water through, around, or in between, and you can even use a bioswale. We've got another slide or two which we'll talk about that. But here, as you can see, the channel water around, and here's your catch basin here. This may have been new construction, or the catch basin's already there. Don't know that for sure. Here's another example. Again, it's going to go through this little drain right here. As you can see, the drain down in this location here. So some of the water is going to go through this location, and anything that doesn't do that is going to go around in front of the curb over here. And the bioswale, the water would come down the curb and go to an area that's typically planted with native plants and soil, and they have a tough texture basically so that they can slow the water coming into the bioswale. And the bioswale also actually can filter the water before it gets into the storm sewer drain water system. And again, any excess flow is going to go around in this location like that. Here's a couple more ideas on your drainage trenches. We saw those in the 3 slides we showed for the bus bulb outs. You saw an example of this type of a drainage where it still flows along the curb line, quite a bit of the flow. That area in between the curb and the new bulb out is covered with some type of I suspect, a cover that can be easily removed because there may be problems with leaves and other debris getting in and under this, and they have to clean them out every once in a while. If that's the case, the overflow, and in any case, the overflow goes around the curb bulb out, but probably the most of it goes through the trench drain, and that can reduce the cost, obviously, in implementation rather than changing your storm sewer drainage locations. On this location, that's a much wider one. Must be an area where they've got a lot of rainfall. Maybe visually too dominant, but it probably serves its purpose. And another example of how it can be done. And they're not too unattractive. So, but again, they must be designed so that they can be maintained. Again, on drainage, here's an example where they actually cut the curb bulb a little bit. The water does flow right in front of the curb cut, and then some of it's allowed to go around the curb here. So that's one way to handle it in this particular location. I personally am not a big fan of that kind of thing, and but if worse comes to worse and you have very little funding, perhaps that's something that you may want to consider. Here are some drainage and landscaping details for your BIOSWALE, and NATCO is the National Association of City Transportation Officials. You can go to that website. The water flows into the BIOSWALE from this direction. You can see that there's a perforated drain here. The water settles in this BIOSWALE somewhat, and the filtered water then is brought out. I think it must be coming this way in this location. The filtered water comes back out into your stormwater drainage system, and it shows that in this slide over here. A couple more examples from a New York City design manual. Here's one for capturing the water in the street adjacent to the park traffic. And then here's another example of capturing water on the sidewalk and channeling it into a BIOSWALE at your curb extension. So they can be used in a number of different applications. And let me show you the next slide here. Portland, Oregon, they have a rather extensive system of green streets, they call it, in Oregon. And they have a rather extensive system of bulb outs with the BIOSWALE in the bulb out to capture the stormwater and then filter it out before it gets into the drainage system. And as I mentioned earlier, we're going to talk about the question on ADA, how do you best handle requirements and guidelines for accommodating persons with disabilities. Here's the ideal situation. Your sidewalk leads directly to the curb cut. It does so from both directions. The curb bulb outs allow you to do that much more effectively than your standard intersection in many cases. And the truncated dome is aligned perpendicular to the curb cut, making it easier for the blind person to identify where they need to go. Now, there are a lot of details in the Portland, Oregon, or the Salem, Oregon. I'd refer you to another agency, or perhaps the Salem, New York, I forget which, that has much more detail about what the depth of that BIOSWALE should be, what kind of plants you have in it, depending on the area you're in. Again, here you can see the entrance for the water into the BIOSWALE. There has to be enough time for the water to sit or reservoir in here to filter the water, and so you can go to those websites and get much more detail if you're really interested in the BIOSWALE application in your curb bulb outs. Okay, mid-block. Another question that was brought up in the pre-questions that we had, and the question is, what do we do about mid-block bulb outs? Are they more unexpected? Can they create problems? And so on. So here's an example. In this location, the agency, you may include bollards. They didn't in this location. They had signs and other street hardware in here that were obviously visible to approaching traffic. As far as your maintenance folks, again, you have to make sure that they are aware where these locations are. As I said, probably more so in the mid-block locations because they may be plowing faster coming down the street, so they need to be aware that they don't run over these locations. If there's nothing here to identify that the bulb is here, that's going to create some problems. The buffer treatment, you don't want your shrubs in that, must not impede the view of the driver that's approaching the intersection. And typically, mid-block considerations are where you have also a mid-block pedestrian crossing location. Not absolute, but that's what they're typically used for. And they've made some accommodations for here for pedestrians, as you can see with these types of things. You can also use special paving treatment to distinguish the ped plaza from the travel lane. And street lighting. Now I can't see it in the slide with the detail on it, but you can see there's a street light over here, and it's behind the crosswalk location. It would be better located up here. That way the street lighting would be forelighting the pedestrian, because over here the street lighting is backlighting the pedestrian at night, and motorists cannot see pedestrians as well with a backlit luminaire like shown in this diagram. So one of the things we find in looking at the slides we try to get into our presentations is that typically there is something there that is not what we would like to have shown in the slide, but nonetheless it's the best slide we have. So you may be noticing things that aren't quite up to snuff as we've gone through here. Just recognize that it's a matter of it's the best picture to show some of the things that we want to make you aware of. Here's another mid-block consideration, street furnishings. You've got planters here, and they may be located on the curb extensions rather than in the sidewalk area back here, make it easier for pedestrians to walk in this area. And the mid-block, again, should be used at mid-block crossings, designated mid-block pedestrian crossings. Here's another location. You can notice that the crossing is not very visible. There are much more efficient ways of doing that, but we won't get into that in this presentation. Okay, again, ADA treatments, what's good, what's not good. If this were a class session, we'd have a little question and answer session here. Give you a couple seconds to look at this and see what you think you can find here. I'll take a little drink of water while you're doing that. Okay. These two truncated domes are really not necessary and shouldn't be there. They would only confuse the blind pedestrian. Okay, they come on one, they go through the, and the water is channeled in between the curb extension here. They go through this little depressed area here. They enter another truncated dome, and then here you have the one that's really necessary before they get into the street. So these two are really not desirable, should not be there. And frankly, I would think a better design might be to have this flat across and cover it with the like the covered trench like we've seen in some of the other diagrams and pictures that we've shown, rather than going to all this expense of trying to do this here. I'm sure they were well-intentioned, but sometimes well-intentioned has consequences that we don't want. Over here in the median, we see that it's a little bit staggered. That's another problem for a blind pedestrian. Should be straight across, or if you have the long enough median island, have the staggered crossing where you get into the median and walk toward traffic and then cross at a location down here. That's one of the more desirable locations. If you can't do that, then it's desirable to go straight across. This location, another thing with their curb extension, it doesn't have a nice radius in front of it, so it's going to be more of a problem for sweep streepers and plow operators if it's in a location where you have snow. More ADA issues. Again, what do you see here? A couple more seconds to try to observe what's going on here. I don't like these as curb extensions. They really don't do what we want the curb extension to do, and that is protect the pedestrian by taking up the whole crosswalk at a minimum. These do neither. This location has a single point access to the street or an apex street, and neither one of these locations has truncated domes. This one is a little bit better as the curb extension does line up a little better with the sidewalk. If you put in a full curb extension, you can see that you probably would be able to line up the crosswalk within the curb extension, the area that you built out, which would be much more desirable. Perhaps this is done because of a cost consideration, but may not even be worth it in this kind of situation because it really doesn't address the strategies that we're trying to accommodate with properly done curb bulb off. Some more site features. This is another couple examples. Controller cabinets, landscaping, poles, benches, bollards, newspaper stands, and other things like that should not obstruct the view of pedestrians or drivers, as well as signs. In this example, the pedestrian crossing sign was located beyond the crosswalk, actually. It is much better over here, but in this location it can block the pedestrian, but there's nothing that says you can't raise this up a little bit and that little pole isn't going to block a pedestrian. So here again, these are examples of an attempt to try a curb extension which will increase the radius and slow traffic down somewhat, but it doesn't do any of the other things that we like with their typical curb extension in improving safety by protecting the pedestrian more. A couple more examples. Good and bad. Again, the sidewalk does line up with the curb cuts, not in this location. Well, yeah, it does too. I'm sorry, it does. However, this one's at a diagonal, not the best situation. They did use the curb extension here for parking bicycles. Must be a nice area where you get a lot of bike traffic, or these bicycles ride to this location and then perhaps get on a bus here and get to their location where they're working, and then back to home at the evening. So a couple good things going on. As you can see here, the pedestrian sign is mounted higher so that it doesn't block, so they can't block, but it's behind the crosswalk in any event in this location. Here's another example. This is a good one. Again, your sidewalk lines up directly with the curb cut. Does in this area as well. The curb extension provides for some plantings, and again, the city of Portland is really big into this. In fact, some of these slides may be from Portland. They may not. You can put planters in them. Again, they're in there for probably visual enhancements as well. They do need to keep watered, but here's a good example: the truncated domes. Again, and they line up with the crosswalks. That's exactly what we're looking for with the use of a well-designed truncated or a curb cut and curb extension. So what about fixed objects? Bollards, planters, and other fixed objects can be placed along the back side of the curb to protect pedestrians where you're using the curb extension to accommodate restaurant patrons, and perhaps you have some benches there for leisure activities for pedestrians walking along the sidewalk, and it will prevent vehicles from getting into this area somewhat and from potentially driving onto the sidewalk as well. So these kinds of things can be used to prevent that kind of incursion into your area. New York City Design Manual, Sightlines. Again, as we pointed out very early on, I think it was the third slide, you want to make sure that you provide adequate sightline between the motorist and the pedestrians waiting at the crosswalk, bicycle, and you also want to have a good sightline for the pedestrian for approaching bicycles and approaching vehicles. There was a question about what do you do about bicycles, lanes that are adjacent to curb extensions. In a case like this, the curb extension or the bicycle lane is beyond the curb extension, so they can adequately get through the intersection with no problem. It's not a good idea to have your curb extension infringe into the bicycle lane. Otherwise, the bicycle may have to shift over, and that puts them at more of a risk with a collision with a motor vehicle. And there have been other, there is another example of where some agencies, the bicycle lane has actually been within the curb extension. They provide a ramp up and a ramp down on the far side for the bicycle to get through the curb extension. I have not seen one of those. They may be out there, but that's what some agencies have done. Also creating, eliminating parking too close and having a somewhat of a good length here, length beyond the crosswalk. Limiting parking in this location further up, like the one where we saw the 90-degree non-standard location in San Francisco. That's not a good design because it can block the pedestrian's view of the vehicles and vice versa. So you need to make sure that you're daylighting properly, and again, emergency operations need to be accommodated as well. Okay, parking integrated with the sidewalk. Here's some examples that we'll talk about. In this case, it's just a schematic which shows that the curb extension is the same material as the sidewalk, and to the motorist, it makes it look a little more restrictive, if you will, and has more of a sense to help them slow down a little bit as they're passing through these kinds of areas. This is only a schematic, but here's a couple examples that show that in better detail. And here we have a before condition, and as you notice, there's no median, a couple of lanes. There's no added capacity with this lane here. It is a parking lane. As you can see, it's very open, probably conducive to quite higher speeds than you'd want in a location like this. And the community came in, they put in curb extensions. In this case, this looks like it may be a mid-block extension. They matched the sidewalk brick with the parking lane, put in a concrete curb like here. It's not raised, but it does have the appearance of restriction to vehicles that are in both of these through lanes, and hopefully slowing them down a little bit as they travel through this location. So it's a real good example of how you can use this along with the median to help slow vehicular traffic down on the streets where you're installing your mid-block locations. So the parking is integrated theoretically with the sidewalk. A couple more locations with parking integrated with the sidewalk. Again, in this location, the parking matches the parking area matches the sidewalk area. In this case, and there's some guidance in some of the other documents you might want to look at that they actually protect the hydrant from being hit with the curb extension that may be located at this intersection. Here's another view of this. Integrated again, the sidewalks looks just like the parking area adjacent to the curb extensions. This question came up quite frequently in the pre-questions. How do we accommodate street sweepers? And we talked about that already, and snow plows. This particular design over here, and I can't see the whole thing because of a little panel I have here, but this dimension is 20 feet. This is from Minnesota. They have the 15-foot radius. Remember, San Francisco likes to have 20 feet for their street sweeper operation. In this case, we have a 7-foot curb extension. And the 20 feet, I suspect, in Minnesota, though I haven't talked with anybody there, is very likely to give the street sweeper or the plow operator enough distance to get back to be able to turn around the corner. If this came out right here like this and just covered the extent of the crosswalk, it would be more difficult for them to stay along the curve here as they came around this corner. And that's my suspicion on why this was done here. But snowplow operators, they figure out how to get it done. You need to communicate with them, obviously, when you're planning any new projects, and they need to know where your curb extensions are throughout your community. Typically, the snowplow operators have a set system that they plow, or the typical streets that they plow during any snowstorm. So they will get used to it, but make sure that the vehicles that they're using can accommodate and get through these locations effectively and do their plowing operations. Now, when they come up to an intersection, they're going to be traveling slower as they plow through the intersection than they would be if they're mid-block and came upon where they might be traveling up to 15 or maybe even 20 miles an hour in their plowing. And again, like I mentioned, the mid-block locations may need to have some more specific guidance or delineation to let the plow operators know that they're approaching one of these. But I can tell you they will get used to it. In my career with the Wisconsin DOT, I worked with the counties quite a bit, and the counties in Wisconsin actually do the maintenance on the state highway system. And so they did snow plowing and maintenance of the grass cutting and so on along their highways. And we did a lot of presentations with them, changes in the manual, for example. We'd go out through the entire state, conduct presentations with them about new changes in the manual, and typically the first thing that happens is they complain about, well, we can't do that. We've never done it that way. But I can tell you, if you talk to them enough about what you're doing, why you're doing it, the safety benefits from the curb extensions, although they're not validated as we pointed out, but we know operationally wise they have a lot of advantages over just a normal intersection location. They will get used to it, and you want to design your locations, your curb cuts, your curb entrances, curb extensions, so that your plowing vehicles can get around them. And as I mentioned, in their presentations, we get a lot of kickback, but over a little bit of time, we found that sure enough, they get used to it, and they're not too unhappy with it. And additionally, they need to plow your entire street system. They're going to have tight corners. They're going to have pork chop islands probably for right turn bypasses at some of your intersections. They're doing that now, and that may be even harder, pork chop island, than plowing curb extension. So they will get used to it. They'll complain, but they'll get used to it. Just make sure that you talk to them about it before you put in a whole slew of them that they aren't aware of. Maintenance, street sweepers. This is a curb extension. It has a very sharp corner here, so you can see that your street sweeper is not going to be able to get in there. The plow operator is also not going to be able to navigate that. It's going to be much better to have the rounded location here than you see here. If you put planters, heavy planters out in a curb extension, I'm not sure this is one, but it's just a picture showing that. Again, you're going to have difficulty with your street sweepers, and somebody's going to have to go out there and hand sweep that location if there's debris and a lot of clutter out there. Can we do it with just paint and delineator posts? You can. And as you can see from this picture, it has been done. There's a little, I'm not sure if this is paint or I guess it is blue paint. And they've tried to do a curb extension just in paint. I, for one, would not want to be a pedestrian waiting out here to get across. I'd still be standing back here on the curb if someone came along and made a sharp and a high-speed turn here. The painting does nothing to prohibit a car from doing that. Here's a little bit better example in these two pictures shown here. They use delineators to add vertical dimension to the curb cut or the curb extension. I want to keep calling it curb cut, but curb extension. Another slide which shows that there's a different texture here in the curb extension. Still not desirable, but perhaps a low cost and maybe even an interim situation on how you could accommodate the curb extension. That is safe for pedestrians that may be waiting out there in the curb extension location. Okay, what if you're having a tough time selling your community leaders on the use of curb extensions? And the cost might be an issue. You may even be balking at, well, I don't think the people are going to like them. We may take a parking space away, and our local merchants are not going to like that. And there may be all sorts of reasons why the folks in your agency think that curb extensions are a bad idea. Well, one way to accommodate this might be, well, let us try one temporary. Go to your management and ask them, can we put it in temporary and let's see what happens. So you can do it like we showed in the last couple slides. You can put in a temporary curb extension, use the delineator post to delineate for vertical delineation of the location. And more than likely, if this is over in use for an extended period of time, you'll find real good feedback from pedestrians that are using the curb extension, and you're probably going to see much better yielding rates for motorists making a right turn to pedestrians that are wanting to cross over to the other side. While you're doing that, during the interim temporary situation, you can develop your cost for the permanent solution, and then once you get the feedback, which is probably going to be very positive, then you can go ahead and put in your permanent curb extensions. And here's the marking shown, the pedestrian signing. Again, this is in advance. It's up high enough that it probably won't block. This was a temporary, looks like a temporary situation over here as well, another one where they've done that. And so there are ways to convince your management, other than looking at like the Cambridge, Massachusetts example that we have, where they, the city fathers said, well, that was so good that we'd like to see more of those in our community, and may even be able to adopt a plan to look at it community-wide, other than just at locations where you may have an existing pedestrian safety problem. Let me go back. There is one other consideration here. What do you do about a blind pedestrian? Suppose you have the truncated dome back here. The blind pedestrian typically is going to stop here and wait until they can hear that there's no traffic coming before they enter on the intersection. But they're going to have that extra distance to cross, or they have the same distance to cross, should I say. But the temporary situation, some agencies have actually taken credit for less time needed for pedestrians to cross during this temporary condition. Not a good idea, because your blind pedestrian is going to be significantly disadvantaged because they need the full crossing time if this were a traffic signal location, for example, where you were doing this. So if it is a traffic signal, do not shorten the time based on from the edge of the curb extension to the far edge of the curb extension if they're both temporary. Just a word of warning, even though some agencies are doing that. What you're really looking for is here, what are the yielding rates, and we're looking for feedback from people that are using this temporary location about whether or not they feel comfortable or whether or not it's a good idea to put these in. And typically you will get good feedback. How much do they cost, curb extensions? Here's a table, curb extension, you can call it that, a choker or a bulb out. The median cost is about $10,150, and this is just one corner. The average cost is $13,000. Minimum is 1,000, perhaps at a temporary, and a full-blown one with all sorts of different things, probably with bioswales and many other things to make it look more attractive, up to 41,000. But if you're looking at a corner and you want to do it on two sides of an intersection approach, 26,000. And if you're doing it on all four approaches, it would be 8 times 13,000, or about 104,000 for a full intersection with curb extensions on all four corners. So it's not that significant a cost. Here's another case study from Arlington County, Virginia. Their problem was that they had heavy traffic and high vehicular speeds, made it difficult for pedestrians to cross Wilson and Clarendon Boulevards near the courthouse station and the Orange Metro Line station, which is located right here. And the corridor is served by 5 underground Metro Rail Orange Line stations and surface tire arterials that form a one-way couplet, each of which were comprised of 3 lanes prior to the pedestrian initiative. Heavy traffic and high vehicle speeds made it difficult for the pedestrians to cross each of these roadways to reach the nearby transit station. The Arlington County Department of Public Works launched the PEDAC initiative in the corridor, and it's a high-density mixed-use area. It was developed in response to the direct public interest in street improvements around this corridor and countywide concern for overall pedestrian safety. The initiative that they developed envisioned a series of small projects to improve conditions for all pedestrians. The solution: they reduced from 3 to 2 lanes. They put in 7 curb extensions built to shorten crossing distances, which also has the effect of calming traffic to some extent, and provide more visibility to crossing points between vehicles and pedestrians. It also left spaces for bus to load and unload passengers, because now they took a lane that was used currently for traffic or parking and used it. Well, actually, it was a through lane, so they took a lane away, and they also removed a dangerous location. Not sure where that was. And they used the higher visibility crosswalks, the ladder type crosswalks, and pedestrian signs installed to enhance the visibility of the crosswalk. Total cost of the project was about $50,000, and here you can see the curb extensions, one of them. They didn't gather any before and after data. If you do some of these, hopefully you will do that and get us some validated evidence about the safety benefits of the crosswalks. The staff and others did report higher instances of drivers yielding to pedestrians. That's what we want. And there was a very positive community reaction, and that's also what we want. And so it was kind of a win-win situation for doing the curb extensions here, again, in Arlington County. And like Cambridge, Massachusetts, it created more of a climate with management on these are really good things, and perhaps we ought to be looking at additional locations within our community where we might be able to install the curb extensions. And I think in particular, if you have locations with existing pedestrian safety problems, the curb extensions are a good tool to use to reduce that risk by the, the protection and the reduced crossing time and exposure by the creating the curb extensions. I did mention that traffic signal efficiency, if you had, for example, the width of the street doesn't matter too much, but if you have 2 8-foot curb extensions, that reduces the crossing distance by 16 feet across one approach, 3.5 feet per second walking speed, that's in the MUTCD. That reduces your crossing time by about 4.5 seconds. So every cycle length, you're going to get an additional 4.5 seconds. If you do it on both sides, or all the corners, you'll have about a 9-second increase in or decrease in pedestrian time needed to cross the intersection. And if you have a 2-minute cycle, then you'd have 30 of those per hour, and the additional crossing distance would be, or the timing would be about that 4.5 seconds times 2, which is 9 seconds, and so you'd have 180 seconds to save time, about 2.5 minutes per hour additional time to allocate to motorists by reducing the pedestrian crossing distance. Okay, here are some of the guidance documents that we talked about, the resources. I would encourage you to look at those, and Oregon in particular, Portland, Oregon, with their Green Streets Initiative. Those of you that might be thinking about that, along with your curb extension, possible use of bioswales, might be interested in what they are doing. So that's the end of the presentation, and hopefully we've covered many of the things that you submitted as questions. If not, Dan's going to now take over, and we'll get into that discussion.
All right. Thanks. I appreciate all your work on that presentation. A lot of good, really good information on a lot of different fronts. And I think, you know, you talked a lot about the webinar questions that were submitted in advance when people registered, and we do appreciate getting those. I think maybe 80% of them had to do with either snow removal or large trucks. And so I think you spent a lot of time on both of those topics because of that, and hopefully some of those answers or those questions were answered with respect to those issues. So I'm going to get to a few other things that came up. First, I wanted to get back to the very beginning of the presentation. Pete, you talked about what is and isn't known about curb extensions in terms of their benefits. And can you just say one more time what we do or don't know about the safety benefits of curb extensions at this point?
Okay, here's that slide.
Oh, I actually screen, but I think I can pull it up too.
Yeah. There are some of the agencies that have installed curb extensions have actually done crash studies, but they haven't performed the before and after crash study, or not over a long enough period of time that the results that they got can be validated by research. So while there is some information, it doesn't withstand the rigors of the research folks. So the information has not been included in the cmfclearinghouse.org, which you can see here that you can get to if you'd like to look at other ones. But if you look, again, if you look at the pedestrian safety, here are some of the things that, again, that the curb extensions contribute to reducing that pedestrian safety risk. And this is the list about the increased visibility between motorists and pedals, decreased crossing distance, the exposure reduced, reducing the speed by visually narrowing the street, slowing the turning vehicles, and perhaps even getting some benefits in your traffic signal timing.
Yeah. And I'd even add to this, I've seen a couple of good things on curb extensions and motorist yielding rates at sort of the uncontrolled locations. So definitely some good benefits there. To the point about safety benefits and CMF, specifically crash modification factors, I noted that the CMF Clearinghouse maintains a CMF's Most Wanted page on their website, and curb extensions is right there near the top. So it's definitely a need, and I'd echo your comment about agencies to collect that before and after data if they're doing these projects to get these, establish a CMF for these so we can kind of spread the word and use that. So I want to get back to the question. You touched on it toward the end, but I think it's worth stating again, the discussion about what benefits you can see in an operational standpoint from curb extensions for reducing signal time or crossing distances, reducing the amount of time needed to cross the street. Can you just say that one more time so everybody can get it?
Yeah. The example that I gave was suppose you have a approach that you want to put curb extensions on both sides of the street. So if you put in an 8-foot curb extension, that's on both sides at 16 feet. So that reduces the pedestrian crossing distance by 16 feet from what the original intersection was. At 3.5 feet per second, that's about 4.5 seconds of reduced crossing time and the 16-foot less in crossing distance. And if you can do a curb extension on all 4 approaches to the intersection, you can double that, 4.5 seconds. So it would be 9 seconds less crossing time. If you had a 2-minute cycle, which is quite frequently in larger municipalities, and that's 30 cycles per hour, 9 seconds per cycle. Oh, that's, is that right? Yeah, 30 cycles at 9 seconds, which about 270 seconds overall. I said, I think a lesser amount than that. You have several extra minutes that you can allocate to vehicular traffic by reducing the pedestrian crossing distance. And of course, by doing the curb extensions, you're also improving safety and contributing to less risk for the pedestrians.
Okay, very good. We got some questions. You mentioned right off the bat that you're only using these in locations where there's on-street parking all the time, where there's no partial use lanes. We got some questions about situations in which there is on-street parking all the time. However, if it's underutilized or rarely utilized, there are some agencies having issues with motorists using that on-street parking lane if no one's parked there as a travel lane. Can you talk about any solutions that you might think of in those situations where you may install a mid-block or a curb extension or a bulb out somewhere, but if there's no one parked in those lanes and someone does use it, that could create a pretty nasty outcome if someone was using that for a travel lane.
Okay, yeah. In fact, we had an individual from New York that asked about that. He had a quite extensive question, and his question was, will they be hit by the snow plows, and they'd install bollards and so on to account for that. And I think as far as the operators, the snow plows who are, complaining about it, again, you have to talk with them, and if your curb extension is in an area with the 24/7 parking, they're going to figure it out eventually. They can fix their own vehicles. They can do a lot of things, these folks that operate the plows and the street sweepers. It's not going to be too difficult for them to figure out when they know where these things are that they can accommodate if you design them right. And throughout the presentation, we give them several examples of how that can be done with the inner and the outer radius of your curb extension. And again, they should be traveling at low speeds at the corners when they're doing this street sweeping and snow plowing. So there's a reduced risk of them doing a lot of damage if they do happen to hit the curb extension at that lower speed. They will disrupt curbs or destroy curbs now without curb extensions, so it may not be a whole lot of difference. But the mid-block locations probably need the extra attention or signing to make sure that they're aware of where those things are when they're doing their plowing operation on the straightaway section. The question was also asked, they had some folks that were driving through on a street in a community that it did not have 24/7 parking. It was only part-time, and they had vehicles hitting the curb extension at night. And the guidance is, or almost a mandate is, if you don't have 24/7 parking, don't put in curb extensions or create 24/7 parking if you want to use that curb extension. Otherwise, you're going to continue to have that problem. And they also mentioned that they had a location where a summertime use of in a summertime area for tourists, where they actually had a part-time curb extension that they used during times when the tourism was high activity, and they used portable planters to supplement the markings I suspect that they had on the pavement to show where those curb extensions are. And then during the wintertime, of course, they removed the planters and went back to the pre-existing situation. So those are a couple thoughts about that.
Okay, all right. Well, thanks, Pete. And that actually takes us right to the end here. If we didn't get to your question, and I know there are several that we didn't get to, I'm sorry for that. I do have our email address here up on this slide. I would encourage you to contact us with those other questions that you have, so we can maybe pass those on to Pete and we can get those answered and get some responses back to you. We do want to follow up on any of these other questions or issues that you're having. But unfortunately, that's all the time we have for discussion today. Once again, I want to remind everybody you will receive an email later today in about an hour or so with a link to the archive page for this webinar, where we've already posted the PDF copy of the slides, and we will be posting the video of the webinar today. I also wanted to let you know that email will include a link where you can download your certificate of attendance. So please be sure to pass that email around your group. If you're the only one who registered, but you've got others with you, let them print out that certificate as well using that link. I'd also like to let you know that a very brief survey is going to appear when you exit the webinar today. We really appreciate your feedback on today's presentation, especially since we have 8 more episodes of the series to go. We do want to continue to improve these and incorporate your feedback in them. I want to say thank you again to Pete Rush for his presentation today, and thanks to all of you for joining our webinar, and I hope you have a great day.